Okay. So, radio project should be done today. I've got a couple of videos of people's radios. I've been able to watch one, a successful radio, and I will watch the others. I'm also in the middle of finishing all the grading for all these projects that we've done recently. Trying to get those grades up so that you can kind of see how we're doing here before Thanksgiving comes along. And then after Thanksgiving, we're pretty much done with the semester. We're almost done now. We're getting close. Excuse me. Let's go to our Sci Toys website again, because we have some questions on the radio real quick. Go down here to radio, and portable crystal radio is the one that we're doing here. And remember, in this version of the build, they actually make a wire coil. They're actually wrapping this coil around this box, so it's actually a really big coil. And then they have these two wires that come off one way and two wires that come off somewhere else as their antenna. But essentially, we've got all these alligator clips connected here. And if you look carefully, you can see that you have the two yellow alligator clips that are going and connecting to the variable capacitor, which is the little, I think it was round, but it should have a knob on it. If it doesn't, it just has a little kind of screw on it that you turn. Some of them had knobs, some of them had screws. But you also connect to that same point on those wires coming off of the coil two other wires. And you have one wire on this side. You can see this wire goes to the little diode that I gave you, which is that little tiny little crystal thing. It's got two wires coming out of it. And then you go from the other side of that crystal over here to your earpiece, and then on this other side, connected to the same coil, you go to the other side of your earpiece, right? And what this does actually is really quite interesting. It doesn't only capture a signal, but it also amplifies it. The combination of this coil and this capacitor actually amplifies the signal, because the coil stores the signal in a magnetic field and then releases it to the capacitor, and the capacitor stores an electric field, and then the capacitor releases it to the coil again, and they push it back and forth, and every time they push it back and forth, they collect more signal and get more and more strength of signal, so that you can actually hear it. So this is not only an antenna, but a magnifier or an amplifier. And this is the principle of all amplifiers. Stereo amplifiers and any other kind of amplifier, they use this principle of storing electrical energy in magnetic fields and in electric fields in the coils of wire and capacitors. What you're doing when you change the capacitor size by turning this knob is you're changing what frequency of signal that this thing is going to magnify. So it actually captures just about every electromagnetic signal out there, but it only magnifies the one that you've tuned into using the variable capacitor. And so that's the reason for that turning knob. And that's how you tune into different stations. Different stations have different frequencies, and that's how you amplify one frequency, you amplify one station. And that's the beauty of this little radio. The purpose of the crystal is essentially to clean up the signal and to translate the signal into a better sound quality. You could actually do this without the crystal, but it's better to do it with it. It gives you a much better quality sound. So actually, without the crystal in this very simple radio, you might get nothing but really bad static. However, the radio that I listened to and the video that was sent to me, they were able to pick up AM1230, I think, because I'm pretty sure it was 1230, because I think I heard Rush Limbaugh on. And then a station really near to that, probably 1410 or 990. Those are two that are pretty close to that station. So they were stations that we could actually hear people talking, you could hear music, you could hear One of them was really quite clear, the other one not so clear, and that happens too. Now, the next thing, since I think that this is becoming successful, the next thing that I want to do is to actually build a transmitter radio. So that was a portable crystal radio. I want to build a transmitter, a simple AM transmitter. And in this case, you're going to need some more electronics. You're going to need a much more powerful inductor. And so I'm going to provide a commercial inductor. But you're also going to need another electronic component that you can't really make. This is what the transmitter is going to look like, and we don't necessarily have all of these parts. I don't have all these parts supplied for you, but I'm going to get them to you. I can't remember if I gave you an AM transmitter kit. Did you guys find in your building kit another bag that instead of saying AM crystal radio, it says AM radio transmitter kit? Should just have two parts in it. The two parts should be this little part here and this little part here. The rest of it is stuff I still have to provide. Did anybody get a kit like that? If you're not sure, you did. Okay, so you guys got it. Okay, so if you didn't get it, you need to tell me and I will send it out to you. But I will try this week to send out to you a circuit board like this, some pieces of wire that you can connect to this thing. I don't know if I can get a headphone jack, but I'm not entirely sure we need a headphone jack to transmit with. And then of course you still have some of these wires, some of these alligator clips that you could use. So anyway, the AM transmitter is going to allow you to put something on the air. So you're actually going to be able to make your own little radio station with this. What's the other? There's one other thing on here. I think that's a battery. So this is a battery connector for a 9-volt battery. I'll try to get that out to you too. But anyway, you should be able to send music now or send voice or whatever else and make your own little transmitter receiver duo so that you can send messages back and forth. So the little metal box here is going to be is a crystal oscillator. It's a 1 megahertz crystal oscillator, and we've got that. And then this other one is an audio transformer. So that's the other piece that's in the picture. That's this piece right here. The audio transformer is essentially just a coil of metal, or coil of copper wire around iron core. So it's very similar to the one that you've got for the radio, but it's a bit smaller in size physically and a little bit better because it's commercially made. And then I'll get you the circuit board. I've got some of those. The phone plug that you're going to use for this is going to be for your sound source. So if you're going to plug it in your iPod or something, we're going to need a phone plug. And I can get you one of those, or you can cannibalize it from some electronics. You know, everybody, you get all these cables with DVD players and iPods and everything else, or headphones. You can just cut one of these things off a headphone, and then you can splice the wires into this thing. It's a little bit more complicated, a little bit more difficult, but you can do it. But I will try to provide some of those as well. I'm just not sure if I have any on hand. I'll have to find some. And then the 9-volt battery clip, you can get it from Radio Shack yourself, or I'll try to find some again. And then a 9-volt battery, I think that I've got some of those as well. So we've got lots of stuff here that we can use. We also need some wire for an antenna. The antenna is essentially just to transmit on. Any piece of wire will work. Needs to be insulated, but I can try to get some of that as well. But the instructions are here, and this is not necessarily something that I need you to do right away. It's just something I want to be done as one of our next projects. And since I've got to get you some parts, we're going to take some time on it anyway. But we want to know that the radio transmitter is on our horizon. I want to do that since the radio worked out pretty well. Any questions on the radio transmitter or the radio project? Okay. Now, as I've been going through some of the logbooks that I've received, and if you haven't turned in logbooks, you need to. Every project from now on should have a logbook with it. But as I've been going through them, I've been noticing that there's some kind of misunderstanding on what a logbook should be. So I'm going to go back and show you what a logbook should be. Again, I've done this a couple of times, but we're going to do it again. So let's go to my other engineering class. It's here somewhere. Let's go back to about here. That's not going to work. Let's try here. And let's get let's see. That's not it, obviously. Got to find something here. Okay, apparently I'm not going to be able to find it that way, so I'm going to have to go online. So I'm going to go to my, this is actually a really good place to make a logbook because it's simple to do and simple to access. I'm going to go to Google Drive. So if I go to drive.google.com, Google Drive is like online Microsoft Word, and anybody can sign in to use it. You just need an email address and you can choose a password. I happen to have an email address that I use for this. What is it? I think that's my Google Drive password or email. What's my password? That's the real question. I think this is it. Find out, I guess. Apparently that's not my password. Let's try another one. And that's not it either. There it is. Okay. So the great thing about Google Drive is that it gives you access to Word-like tools so that you can create documents. If I hit here, create, I can create a document, a presentation like PowerPoint, spreadsheet like Excel or whatever else. I can even do drawings and whatever else. You can create them, but it gets saved automatically while you're writing it. You never have to worry about saving it. And you can share it with people very easily. You can make it so more people can write in your document, more people can change your document or view your document, whatever. But the point of the logbook is that it should be like a journal of the stuff you do on the project. So here's a logbook of a team that we're going to build some magnets for a generator for a windmill. And you can see here that we have 10/23/12, that's the date. This is their first meeting of the magnet team, and this is what their objectives were: to share documents. So they're going to talk about this logbook. They were going to share contact info and skill set determination, what they're able to do. So they gave so everybody wrote down their information on the team so that they could all contact each other very easily, and then they discussed what they were good at and everything else, and maybe they should have written that down, but they didn't. The second time that they wrote something in their logbook was the 29th of October, and he just writes a little paragraph of the things that they wrote down, things that they did, right? And it's simple stuff. Here they said they found a website researching magnets, and so they put a link to the website in there. They wrote down what the website was. And then they talk about what they've done, and they get to a point where they're actually writing things down that are important to the project. So this is what they call an objective tree, which is what they want to do is they want to build this housing for this magnets, and these are all the things that they're going to have to do to get it done. Here they have a list of the things that they need to accomplish and their importance on a scale of 1 to 10. Here they have a list of the different documents they need to get done so that they can get them done and when they have dates that they want them to get completed by. Here is one of those documents, so they actually put the document in here. When they do their design, they're actually going to put their drawing in here. So here's a file that they're taking a picture of something. Here's some ideas of how they're going to do this. So they've scanned this in. You should have images, you should have drawings, you should have pictures, you should have links to things. You should have all the information that anyone would need to redo your project. And if it doesn't have that much information, it's not enough. If it has too much information, that's okay, but it's still not great because then people have to sift through too much information. But too much is better than too little. It should not just be a list of, I did this on this day. It should include all the information from what you did. So if you spend some time looking at designs on the internet of trebuchets, then you should put a link to maybe a couple of the websites that were most important to you, and maybe the 3 or 4 designs that you're thinking about doing. You should put pictures of them, or you should put links to them. And then when you choose a design, you shouldn't just say, I chose this design, it's called this. You should include a drawing of it and talk about the parts you're going to use from your kit in it. It should be much more detailed than most of the logbooks I'm seeing. It's not just to tell me that you worked on the project. It is to tell anybody how to redo this project, how to reinvent your project, so they don't have to reinvent the wheel. There are lots of good examples of logbooks out there. This is one that's decent. Let's take a look at a different one here. This one is an example one. No. So here is another one, a different group, and you can see that they had a meeting and they talk about repairing a housing or something. They need to buy these things, and so they wrote them down, right? And then they said the paint is the key to the durability of the fiberglass. This is important. It has to get rid of the UV. They talk about who was taking notes, and they talk about ideas that people make. So Echo talked about this particular thing at this particular store, Premium Auto Mix. The Mid-Plains Auto Finish in North Platte. They talked about what product they needed to use and how much it costs and how much they're going to need to use. Here they have their objective tree. They have, all kinds of documents and drawings and charts to show what they're doing, so that I could go in there and I could redo their project without ever having to talk about it. Then they link to a presentation. They give a presentation on this project and they linked it into here. So if I click on this, I should be able to see their presentation, and so on and so forth. So lots of pictures of when they actually start doing things. So good stuff, but you need to have, here's a tool that they designed to make one of their parts, so they show how this tool is designed, how it's made. So you should be giving enough information so that somebody can recreate your project. Can't just be a list of things I did without any details about those things that were actually accomplished. So Google Docs is a great way to do it. It's very commonly used in the engineering fields and in general. A lot of people use Google Docs nowadays because if I write a paper and I want somebody to read it, I can just email it to them really quickly or just share it with them, and they can go in and make changes to it and make comments on it, and I can go and look at their comments very easily. It's a nice thing to do. It's also a really nice way to post documents on the internet. So you can make these documents available on the internet to anybody who wants to look at them. And just show you, they just need the email. They just need the web address. You can share the web address with them. They can go look at it, or they can change it if you give them permission to change it. So lots of things like that. This is one of those documents that is available out there on the internet. It's one that I use for my class, and I just constantly am adding things to it. My students can add things to other ones. Excuse me. So, you can do it in Microsoft Word or any other program you want, I don't care. But it should be more like a journal, or maybe even a scrapbook, you might think of it as. A scrapbook / journal or diary, where you're keeping track of the things that you do every time you work on the project with details. The important details necessary to recreate the project. So, Having said that, every project will have a logbook from now on. Every project you do. So every time we start a project, start a logbook. Electronic is best. You can do a written logbook and fax it to me if you want, whatever, but electronic is best. It's easier to share. It's easier to keep track of. Besides that, we are now into what project now? I can't remember what's on the list. I think we're still in the radio project, actually. We do have one. Let's see. I'm going to go look it up. Let's go look it up, since I can't remember. Okay, so we had our motor project and the radio project. So the radio project apparently is supposed to go on till the end of next week. Since, well, we can go ahead and do that. Let's go ahead and work on with the radio project. I will try to get you some more parts, but actually, you know what? I'm not going to do the extra parts. You go find the parts. I'll let you find the parts. You do not necessarily have to have a solder board or a circuit board to work with. You can improvise something, and that can be part of your project. So all the rest of the parts needed for the AM radio transmitter kit, you need to essentially cannibalize. You need to go find them. You can find them in other old electronics. You can find them in your garage. You can find them from a teacher. I don't care how you find them. Don't go out and spend a lot of money. That's not the purpose of this project. But you should be able to scrounge together enough parts to do this and get it done. So I want you to build an AM radio transmitter now. And you have, see, today is Wednesday. I will give you till Monday to do that. And then the idea will be to transmit from one radio to the other. So you have to tune them together, tune the one to find the other, essentially, right? So that's your next job in the radio project. Eventually, we'd like you to be able to send some message or send some music from one room to another, and have it come in nice and clear, nice and loud and clear. So, any questions on that project? You should start a logbook. You can use the same logbook as your radio project if you want to, since it's kind of a continuation. But you should have that transmitter done by Monday so that you can test it and make it work. Okay. Now, essentially what we'll do is we'll try to get this project out of the way here. If we can get everybody's radios working by Monday, then we can have a little extra time for our hydraulic arm project, which I think we might need. We'll start studying hydraulics next week a little bit, give you some background information on how they work, and then we will put you to work on the hydraulic arm project. It should be a fairly complex project. There are moving parts in this project that have to be fairly fine motor movement. You have to be able to get them to work just right. So a lot of tuning, a lot of reconfiguring and fixing and redesigning probably in that project. So we've given ourselves a week and a half for that project, or a week and a day. We might take in a couple extra days next week if we can get this radio project done and working. Then, as soon as we're done with hydraulic arm project, we can move on to three-dimensional design. If we get done with the hydraulic arm before Thanksgiving, we'll start three-dimensional design early. If not, we'll start it after Thanksgiving. And we'll take a week to learn how to use SketchUp and how to design in 3 dimensions. And then we'll take another week to actually do some designing and prototype our design. And then there will be one more presentation on that particular project. You will actually have 2 more presentations, one on hydraulic arm and one on the final project. All those presentations essentially go in as, let's see, I think those go in as exam grades in this class. Let's see what they look like here. Yep. So your exams are essentially your presentations. So make sure that you do a good job on your presentations. So far I have 3 presentations from your trebuchet project. Everybody should have turned in a presentation for that. That's an exam. So get it done and get it turned in. I need to watch, I want to watch all those together at one time so I can grade them together at one time. It's the fairest way to grade everybody, so I want to get that done. Send in your presentation on your trebuchet project. Send in your log books from your trebuchet project, from your motor project, from your radio project. Get those in as well, because you see here, log books go in as project reports. So those are 25% of your grade. You guys have all got homework turned in for the most part. We're doing pretty good there. But we need to get these grades filled in so that we can get everybody a nice grade for this class. Not a terribly difficult class. You shouldn't get bad grade in this class as long as you do the work. So, anybody have any questions? Any concerns? Okay. We'll see you guys Friday. We'll check up on your work on Friday. And you guys can go ahead and get started collecting items for your transmitter project and getting going on that. You have till Monday to finish it up. On Monday, we'll start taking a look at how those are working. If you need a little extra test time to make it work, I'll help you out with that. But we want to try to get done with that by Monday so we can get started on the hydraulic project. I'm done today, so we'll see you later. Have a good afternoon.
What should I do with my radio?
Well, you should try it again to try to make it work again. But if you can't, bring it in. I'll be here this afternoon a little bit until about 1 o'clock. At 1 o'clock, I'll be gone for a little while, and then I'll be back again, probably around 2 or 3. And then, let's see what else. Tomorrow I'll be here all morning. In the afternoon we'll be throwing pumpkins. So, bring it in here, I can help you out, or you can try it again yourself. Make sure that you have the wiring done exactly correctly.
Put it all on exactly as it showed in the little diagram.
Right? Check, double check, and double check. It's really easy to get wiring incorrect.
Okay, well, I checked it, then my dad checked it. My dad's a professional electrician.
Okay. Also make sure that you have contact. Make sure the wires are scraped free of their insulation. So if it doesn't look really bright gold, if it looks coppery gold, then it's probably not scraped free of insulation. Not getting a good contact. Because the insulation is essentially just a lacquer. It's just like a clear paint.
We got it all soldered together now.
If it's soldered together and it's not working, the only thing that I can think is that it's not quite together correctly, or that it's the diode in it might be in backwards.
That picture, the one of the finished product,
shows the diode in the way that you have it in. Okay. The diode may be broken, so we might have to replace the diode. It's a possibility. So if you bring it in, we'll test it out, we'll check it out. Okay. If nothing's working, we'll give you a new diode and see if that works.
I think I'll bring it in tomorrow morning. I got a class pretty early.
I'm done with class at 10 o'clock. So I'm
class
available.
is done at 10:30.
I'm available after 10.
Okay.
Till 1. All right.
All right. I'll see you.
Yep.